definitely a case of don't stop till you're done. Is this a perfect square, x to the fourth?
Yes.
Yeah. Any even, if it's not an x squared, if it's an even exponent, it's still a square. Because what this means, x to the fourth means x squared times x squared. It's a factor times itself. Because, you know, our product rule says add the exponents, right? That equals x to the fourth. Okay? So our a, and another way to think of it is like if you can write something squared, okay? So if you can put empty parentheses in a square and you can write something in there that makes it equal this, well, I can write an x squared here because 2 times 2 is 4. And this would be?
25.
Yes. Okay. And so my a is x squared and my b is 25. All right, so there's my a and my b. So this is x squared plus 25, x squared minus 25. Okay. Now, are these linear? I got my two binomials, I got my conjugates, but are they linear?
No.
No. So I'm not done yet, maybe, but I certainly need to check. Can this be factored further? No, it's prime. Okay? Now this is a factor, it's a good factor, but there's nothing else to do with it. Okay, so once your factor is linear, or at least it's prime, you're done with it. So it's part of my answer, but what about this one? Yeah. It can be this is a difference of squares, so I can keep going.
5.
What's my a?
X.
And my b?
5.
Yeah, so x plus 5, x minus 5. That factor could be factored further. Because it was not linear and it was not prime, so I could keep going.
Oh, you did it twice with the first.
Yes. And that's because, one, this is a double square. Okay? X times that, x squared is x squared, and then x squared squared is x to the fourth. This is also a double squared. 5 squared is 25, 25 squared is 625. So if you've got two double squares, you're going to get two factors. One of them will be prime because it's conjugates, and the sum is prime, but one is negative, one is subtraction, and you can keep going. Yeah. Okay, so you're going to see all of these represented in the homework. This really is a matter of just getting comfortable with it now. Okay? And I'm available in the lab, and I'm available via email, but these are things that, especially difference of squares, you need to be able to do in your sleep. Okay? So it's about recognizing them and then just breaking them apart. Conjugates. No middle terms, conjugates. So, let me show you the difference of cubes, sum and difference of cubes. Okay. All right. So, sum and difference, this is also a 9.3. Sum and difference of cubes. All right. So this I use for this, as I showed you, the formula is this. If you have an a cubed plus b cubed, perfect cubes, sum of perfect cubes, then it factors into a binomial, a plus b, and a trinomial, a squared minus ab plus b squared. And if you have a difference of cubes, it factors into a binomial, a minus b, times a trinomial, a squared plus ab plus b squared. And if your brain is already cramping up, that's fine and normal. Do not think you need to memorize these formulas, but do understand the basic pattern. If you have to recognize if you have a sum or a difference of perfect cubes, and if you can find your a and your b, just uncube them, just like we unsquared. Once you know your a and your b, I'm going to show you a trick for how you know that it's going to factor. You just need to know it factors into a binomial times a trinomial. And what that pattern looks like, I use a little setup called this.
Okay.
This is, I call it SOAP. Now, that's all capitals because this is an acronym inside of an acronym. So, SOAP stands for something, and the acronym is SOAP makes it simple. Okay? So, SMS is the first acronym, and SOAP is the second acronym. Okay? What that means is, here's my SMS. I draw an M, and there's arrows on the bottom for a reason. And this is not a 5, this is a little s. So SMS. Okay? Now notice how many points are on top of an M?
2.
And now how many on the bottom?
3.
3. the top 2 points are your binomial, and the bottom 3 points are your trinomial.
Oh, so A2, negative A would be.
Yes. And all you do right here is you find your A and your B and you put them on top.
Okay.
And then you square your A, that's your first trinomial term. You multiply your A and your B, that's your second trinomial term. And you square your B, and that's your third trinomial term. And then SOAP is going to tell you your sign pattern. Let's see what that looks like. Okay? So, if you've got x cubed plus 27. Okay? Now, just like knowing, that's another thing, just like knowing perfect squares, knowing perfect cubes up to a certain point is good. 1 cubed, 2 cubed, 3 cubed, 4 cubed, 5 cubed, 6 cubed, 7 cubed, 8 cubed. I never remember 9 cubed. Wait, that's 6, 7, 8. I think it's 729 actually, yeah. And then 10 cubed. Yeah. And if you don't know them,
oh, let me write them down.
well, you can do that on your calculator, make a list and flashcards later. It's like knowing your multiplication facts.
Okay.
But also, you can check it in here with the cube root button. Square root button to check squares is over here. Cube root, you have to go into the math key. Okay. So if I wanted to know if, say, 729 was a perfect cube, I go math, and it's right here in the first menu. It's number 4. Okay. And so cube root, if I wanted to cube root 729, yeah, if I get a non-decimal answer, it is, because 9 raised to the cube is 729. Okay? So that's going to tell you something's a perfect cube and also tell you what its uncubed version is. All right? So that's most of your work. Identify, hey, that's a perfect cube, so my A uncubed is x, and 27 is a perfect cube, so my B uncubed is 3. Okay? You're uncubing, not unsquaring. Be careful with 64, because 64 is a perfect square and a perfect cube.
Yeah.
So make sure you know what you're thinking. Am I unsquaring it or am I uncubing it? Unsquared, it would be an 8. Uncubed, it would be a 4. Yeah? Now, my SMS looks like this. I draw my M. My A and my B I put on top. X and 3. There's my binomial. Boom. Okay? Now my SMS, this means square multiply square. So, square x squared, yeah. Multiply, square, 9. Right? So, here's my binomial, x and 3, my top 2 points, my A and my B, and here's my trinomial, my square, multiply, square. Now, all I need now is my sign pattern. Is it pluses or minuses? Well, that's where SOAP comes in. SOAP means same, opposite, always, writing vertically, always positive.
And they're all positive.
Yeah. So this is same, opposite, always positive. Huh? So, was this a plus or a minus?
Plus.
So, the binomial is the same, which makes this the opposite, so it is.
Oh.
And this one is always positive.
It's so easy.
Right?
Like easy, yes.
Okay. All right. So here is. There's a couple of really big ones. So we'll have time to at least do one, and we'll So 343 x cubed minus 512 y cubed. Oh, this one has variables on both sides, but they're perfect cubes.
Yes, ma'am.
So you've got to know first, are the coefficients perfect cubes? And if so, what are they uncubed? If they're not perfect cubes, then you can't factor this.
It's 7.
Yeah. However, but I also want to show you, now you can see from my list here, they are perfect cubes, right? But remember, what's the first thing you do? GCF, yeah? Yeah. So remember, you can, especially with big numbers, you can check this in the calculator, remember on the math button, and go to the number menu, and go down to number 9. You can scroll down and push enter, or just push 9 when you remember that.
What is that for?
That's to find the GCF. So if you're not sure if there's a GCF, which you always need to check first, GCD, which means GCF, comma, which is above the 7. Don't put in negatives or it'll give you an error, so it's just 343, comma, 512. And if it returns a 1, that's the only GCF, so there's no GCF.
Oh, wow.
Okay.
What did you do
Huh?
today?
And you go that math button, which has lots of menus, but you stay on the first menu. So math, and you scroll down, or once you remember it's number 9, you can just push 9, or you can scroll down to 9. Wait. Oh, no, I'm sorry. It's math, number menu. It is the second menu. Math, number menu. And now scroll down, or push 9, or scroll down to 9 and push enter. And then you enter your two numbers in positive form with a comma in between, and the comma is above the 7. Okay? And if there's a GCD other than 1 that you have to pull out, then it would tell you that GCD, the GCF. Now there's not 1 in this case, so now you know that there's no GCF, so now you see if they're perfect cubes. Hopefully you recognize those are, but if not, remember you can go to math, number 4, and see 343, and it tells you 7. And if you do the same thing for 512, it'll tell you 8. Okay. So, what is my A in this case? Uncube. 7, right? And then, because 343 uncubed, 7 cubed, or 7 times 7 times 7 is 343. Cube root of 343 showed us that. Okay. And so it's 7x. Okay. And 512, there's no GCF, and 512 is also a perfect cube, so what is 512 uncubed?
8y.
8y, good. Now you've got variables on both of these, so don't forget the y on this one. Okay. All right, so SMS, I already have my binomial, because it's my A and my B, 7x, 8y.
Okay.
Square that 7x, what do you get?
49.
49x squared. Multiply
56.
xy, good. And square
64.
y squared. Huh? There's your trinomial.
I love this method.
Top 2 points are your binomials, 7x and 8y. And the bottom points, the square multiply square, is your trinomial, 49x squared, 56xy, 64y squared. And then SOAP
Okay, hold on.
for your signs. Same, well, you have to go back to the original problem. So the binomial is, and then opposite, and this one is always positive.
I like that little method.
I have time to put one more up here. I'll leave that to you guys. This would be 648 m to the 4th plus 3m. I'll leave the example up there too. You want to start?
Yes, ma'am.
Question? Here?
Yeah,
Okay.
yeah,
Okay.
yeah. Okay. That's cube to the 4. Go ahead. I'm sorry.
Yeah, see, remember, especially with binomials, sometimes you can fix it at the end, even though it's messy. But with binomials, if you don't take out a GCF, you may not be able to move forward. I mean, yeah, you think, oh, 4th, hey, this could be a perfect square. But wait, there's an m there, and that's not a square. And those numbers, I don't know about 648, but I know 3 isn't a perfect anything. So you can't even move forward and fix it later. You have to, with binomials, you have to take out a GCF first, because you don't even know what you have yet. Huh? You don't even know if you have perfect squares or perfect cubes. Huh? Is there just a numerical GCF? Yeah,
M.
right.
So what about that 4? You don't put that 3 and 4?
No, because you have, the M, 1M is the most they have in common. You can't, you mean put in, taking out M to the 4th? Well, that would cancel it out here, but then that would leave M's on the bottom over here. Yeah. No, you can only take out the smallest thing that they have in common. Yeah. Or the biggest thing they have in common, which is going to be the smallest thing. Because you can't take out more than what any of them has. The numerical GCF is always going to be the smallest one or smaller. The variable GCF is always going to be the least number. There's 4 M's here, there's 1 M. The most they have in common is 1 M. So that means 216 M cubed. Don't forget that this is part of your answer. Plus 1. So A is 6M. Square, multiply, square. Once you have your A and B gave you your binomial, square, multiply, square gave you your trinomial. Don't forget your original GCF. So the former, your final answer, is 3M, and then your binomial, and then your trinomial. Done.
I don't understand the soap.
I didn't understand it.
The what, sorry?
I don't understand the soap concept.
The SOAP? It's just an acronym, meaning it's letters that stand for same, opposite, always positive. So all this is to know whether to put in pluses or minuses.
How do you know if it's a plus or a minus?
Because by same, the S in SOAP, same means this sign is going to be the same as the original problem. Opposite means the opposite. So if this is a plus, a sum of cubes, then your binomial is going to be plus, and the next sign will be net minus. If this were a minus cube, then your binomial will be minus, and the next one will be plus. But the AP, always positive, this last one is always plus, always. Does that make sense? Okay. All right, I'll be down in the lab in 10 minutes. And here's the things I'm going to post, but you can photograph them if you like. And does somebody have a problem they still need me to look at?
Well, you can fix it for me. I was just wondering, how did you get the 216 M?
Because dividing out the 3?
Divided,
Yeah.
So that's what I got it.
So first I put in to find the GCD of those two, found it was 3, and then I could just do 648 divided by 3 to see what was left behind.
Which one was the